Okay. Yeah, it's still a bit of a delay. We'll deal with it. All right. This problem here has a lot of steps to it. It's kind of complicated, but really it boils down to just a lot of algebra and dealing with altitudes. Okay? So first of all, altitudes of a triangle. The altitude of a triangle is its height. So you think like airplanes have an altitude, that's how high they are above the ground. Well, in a triangle, how tall the triangle is its height. That's one way of thinking about it. Specifically, it's the altitude is a line that stretches from one vertex of the triangle to the opposite, and is perpendicular to the opposite side. It doesn't actually have to touch it. For example, here we have a triangle where the height of the triangle, it would be measured outside the triangle. So it doesn't actually touch the opposite side, it's just perpendicular to the opposite side. So again, the altitude is a segment that is perpendicular to the opposite side of the triangle and passes through the one of the vertices. Okay, but in this case, our altitudes are all inside the triangle and actually touch. Now, the second part about the altitude is it's how we would calculate the area of the triangle. So the formula base times height divided by 2. Base is the side, and height is the altitude. But we could also measure this area triangle. I could turn it around like this so that I have base and height. Or I could, I guess, turn it the other way. Whoop. Turn it all the way around here. If I can get this in here. There we go. Base and height. So there's several different ways we go about that, calculating that area, and we're actually going to use that fact to do some work with these. So what we're going to do is we are going to calculate the length of the altitude using two different methods. One is going to be super complicated and one's going to be pretty easy. The super complicated way is going to be to write an equation for this line and write an equation for this line, and then we're going to find the point they intersect and calculate the distance between the 2 points of intersection. That's the complicated way. The easy way, hey, what's up, David? And the easier way is that if we already know the area of the triangle, we can just work backwards to find the height of this, the length of this segment here. Okay. So let's start by finding the area of this triangle, right? So the area of the triangle is area equals 1/2 base times height. That's 1/2. Our base is 1, 2, 3, 4, 5, 6, 7, 8, 16. And our height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So area equals, where's my calculator so I don't botch this up? Alright, so that's 8 times 18. Clear. 8 times 18. That's 144. So the area of this is 144 units squared. We do need to find the length of AB. So I'm going to use Pythagorean theorem on that. AB squared equals, and this is over 8 and up 18. So 8 squared plus 18 squared. So 8 squared plus 18 squared is 388. So AB equals the square root of 388. All right, so if we know the area and we know the length of the base, right? So if we're counting this as the base, then we can figure out the height by just rearranging our formula. So our formula would be 2a over base equals height. So I just rearranged the formula. Right? So base times height would be equal to twice the area. So, yeah, anyways. So 2 times 144 divided by square root of 388 would be equal to, now here's where that's h. We don't want to leave a radical down the denominator, so I'm going to multiply the numerator and the denominator both by square root of 388. So let's see. Boy, actually that's just going to be a big, ugly mess. Let's just leave it as is for now. That's 288 over square root of 388. I'm going to put a little star here as a reminder that that really isn't proper. We shouldn't leave that radical down there, but we are going to leave it there just for now. Okay, so that would be the length of this diagonal, right? We found CG. So now we're going to find it the hard way, but we're going to do this one over here instead. Right? But they're the same length because this whole thing is symmetrical. So let's see. First we need to find an equation for BC. So let's see, a point it passes through is, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 16, 0. And its slope is down 9 over 4, so it's negative 9/4 on the slope. So the equation is y equals negative 9/4 x minus 16. And then it would be, I guess, plus 0. Oh, man. So y equals negative 9/4 x plus 16 times 9, 36, plus 36. We'll use our distributive property. So there's our equation for BC using point slope form. Next we're going to find the equation for AF. So that point passes through the point 0, 0, so this will make it easier. And our slope will be the negative reciprocal of slope of BC because they're perpendicular. So the negative reciprocal of 9/4 is 4/9. Okay. So our equation will be y equals 4/9 x minus 0 plus 0. I just added those in because I just want to show us filling out the form, but really it's just y equals 4/9 x. Okay. Now we have the equation for both lines. We're going to find point F, which is the intersection of those two lines, by just setting the two equations, like, I guess, quote-unquote, equal to each other and solving for x. So our original equation was 9/4 x plus 36, or negative 9/4 x plus 36. So negative 9/4 x plus 36 is equal to 4/9 x. So let's see, I need to add 9/4 to each side, and here's where the handy-dandy, instead of fiddling around with a common denominator, I'll just go 9abc4 plus 4abc9 gives us, let's see, 97/36. So I have 36 equals 97/36 x. And they have to divide by 97/36. Again, I'm just going to take to the calculator here. So 36 divided by 97 over 36 gives us 1296 over 97. Yikes. Equals x. That is a horrible number. Let's just take a look at what that is again. It says 13 and change. So let's see if that kind of pans out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and a little bit more is the x-coordinate for that point. So looks about right. Okay. Now, we found the x-coordinate. Now we need to find the y-coordinate by just plugging it into one of the equations. I think this one looks a little easier. So y equals 4/9 times 1296 over 97. And again, I'm going to go to the calculator. There's that number. Times 4 ABC9. That gives us something that's a little over 5. Let's see if that looks, almost 6. 1, 2, 3, 4, 5. And it looks like it is almost 6. So I think that's reasonable. And that's 576/97. 576/97. That's just a horrible number. Nope, 576/97. It's right there. So now we'll write the coordinates for our point up here on F. That's 1296 over 97, 576 over 97. Now, we need to find the distance from A to F. Okay, so let's do that. So AF is, using distance formula, okay, from 0 minus 1296 over 97 squared. And our y-coordinate is 0 minus 576 over 97. And I'm just going to punch all this into the calculator. I don't really have to write in the minus parts. And in fact, positive or negative doesn't really matter either, so I'm just going to put in, there's our 576 over 97. I'm going to square that, plus 1296 ABC 97 squared. Calculator's going to think for a second. And then second, square root, second, answer. Ooh, except I don't want that. It's going to give me a decimal. Up. Oh, shoot. I didn't want that. Let's go clear. 576 ABC 97. No. 576 ABC 97 squared plus 1296 ABC 97 squared. Oh, that's going to be ugly. Okay. Second, ABC, enter. Okay. Look at this number. This is terrible. It is the square root of 20736 over 97. Okay. And then I'm going to do, I'm just going to see what that is approximately as a decimal. So now we'll go, and it is 14.621 approximately. Now let's see if that compares with our answer from earlier, which we left as this terrible fraction here. So let's see, we have 288 divided by square root of 388, 14.621. So we get the same answer either way. Easy way, complicated way. And was there anything else we were supposed to do? Yeah, I think that's pretty much it. Okay, it does talk about checking your answer by multiplying. So I should be able to take this horrible number, which represents this length, and multiply it. So base times height would give me twice the area, and so I should get, what was the area, 144, I should get 288 when I do that multiplication. And this whole thing right here, by the way, should simplify to, see, 288 over there. That's going to be a terrible number. Okay? But you get the gist. So here are your basic skills that you're working on. 1, area of a triangle. Recognize that the area of a triangle base times height is base times height, but there's any orientation. There are 3 different base height pairs. And if I want to find out what the base of the height is and I already know the area, I can work backwards. Second of all, writing equations in point-slope forms. If I know a slope and I know a point, I can write the equation of a line. That's a skill we need to work on. Next, writing equations of perpendicular lines. So if I know a point and I know the line, the equation of the line I want to be perpendicular to, then I can take that negative reciprocal of the slope and write a new equation. Next, finding a point of intersection of 2 lines. So writing the 2 equations and then setting them equal to each other, solving for x, and then evaluating for that particular x value to get a y value, right? So setting the 2 equations equal to each other, solving for x, plugging that x back into one of the equations to get a y. If you want an extra double check, you plug that back into both equations to make sure you get the same answer. And then finally, finding the distance between 2 points using the distance formula. So a whole bunch of skills all wrapped up into one big complicated problem. That took a while.